Hello, welcome to this your fifth tutorial on the Emissions Calculator app. So far, you have learned how to deploy an app built within the source code in Python and Flask and synchronize with the Heroku cloud environment to have it up and running. As far as I could supervise within this week, all the three groups are either with their apps up and running or very close to have the app in full shape. So this week we're going to cover a very important task, and that is related to the emissions calculation methodology, or you could relate it as the machinery that gets you the information from every individual user. We're going to have a reduced version this week because, very importantly, I will give you some slack so you could prepare for the next week, week 10. A 15 minutes presentation that could be arranged as you wish, where you're going to cover some topics that I have included within the module and also in this PowerPoint. So this week we're going to learn about mathematical operators in Python, or if you like to call it, the translation of how mathematical operators looks like in Python syntax. Then I will present how to introduce your selected method as part of your app. As you may recall, all the previous week, at least the emissions methodology group, main task was in gathering calculation methods. So this week, within the whole group, and especially the emissions calculator, the emissions methodology group, could select the desired method that is going to work as a default within your app for the following weeks. Then I'm going to talk a little bit about criteria for selecting a method that fits an app. Perhaps that section will be self-explanatory, though this has to do pretty much with what I have experienced so far by developing apps. So without further ado, we're going to start with the mathematical operators in Python. This is a very simple topic, though I thought it was necessary to explain it in order to have everybody clear with what does the translation looks like. Together with the regular operators, plus and minus are very evident. Some important operators that you might use when introducing your new methodology within the code are, at least when you like to make a division, is the regular slash symbol. A multiplication is translated by a star symbol, and whenever you like to introduce an exponential, that includes two stars symbols. The case of the square root, that is either an exponential 0.5, or you can include a module called math and then call an expression called math.squared for square root, and then the number you like to have the square root of. Be aware, and this is quite important, that the order of operations, the one that you learned from regular algebra, regular math, also holds in Python. That is that you first have the operations within an exponential, you then have an operation within parentheses, and you got exponential square roots, multiplications, divisions, lastly summations and subtractions. For example, this expression over here is not the same as this expression over here, at least it's not going to give the same result. And you should be aware, at least when you introduce your method within the app, that it is well described, otherwise you will start building up faulty records within your database. So without further ado, I'm gonna introduce on the sections of how to introduce your method within your app. I am going to take the example of group 3 this week. So as far as you recall, We have some information within the repository in our group. This week we're going to focus exclusively on the app PY. This is very sensitive, meaning that there might be some changes that will make our app to crash if it does not like sync properly with databases and information that is within the code. So what I suggest is that keep a version of this one, or at least copy a backup within your own repository that is going strictly to download it by means of going up here, download the code, download zip. Then you take the file out and you upload it to the repository. I'm not sure if there's a way to copy files within the repo. I owe you that one. Perhaps I have to Google afterwards, but at least that's one solution. Download the whole file. Just grab your app PY, change the name of the app PY outside of the repository. Put something like app backup, because remember that this is the one that the Heroku recognizes. Try not to change the name of this one. Bring up and upload the app backup and have it hold that in your repository. That's just in case something goes wrong, right? So the first thing is to try to explain the method that I use as a default for this app. I have used UK government greenhouse gas conversion factors. Some of you also include that as one of the options within your code, and I have included that one first because it is backed up by a, let's call it, a strong source. Secondly, because it's simple. It only requires to have emission factors that are also provided by the UK government greenhouse gas group. So I have included something called dictionaries that holds all the emission factors per transport mode and also per type of fuel. The emission factor is no more than a conversion of how many grams of CO2 or methane a specific fuel produces within a transport category. Of course, these could be segregated even further, and the level of details belongs to the developer, or at least the group that is sponsoring the app. So keep that in mind. I will make an explanation of what it is. This in Python is called a dictionary, and as a dictionary it has keys that are described with these quotations around the string name or the text name to identify that this is a string. Then you have a colon, and everything after the colon is going to be a value for that string. Okay, so every time you got a colon, that means that there's a new definition. What's happening here is like if you call the key boss, it will return all this dictionary, and then when you call boss and then diesel, it will give you specifically this number here that holds for the kilograms per passenger kilometer transported in a bus and using diesel oil. So that's pretty much what is behind this section over here. Add a new record. So what happens in here is that the kilometers are introduced. You take this one and then the fuel type. Okay, so the records that comes within these two sectors comes directly onto this definition and returns this specific this specific emission factor. Okay, a very simple version of what we've done so far. It did the same for methane, even though we're collecting it. I don't think that at least on this first stage is very, very critical, at least for our expected outcomes. Right, so if you want to change the emissions factor, you are free to do so. Just change the factors within these blue spaces. If you want to even add additional groups, you can do so by adding more keys inside here, right? So the next thing to know is like, where are the calculations done? One of the calculations comes strictly at least for group 3, from line 345 to line 350, and that belongs to two cases. I'm doing an if statement saying that if nothing comes from here, so if nothing is added here, a number for specific kilograms per passenger, then take the kilometers, and from the dictionary, remember the dictionary, take the value of the transport, in that case it's going to be bus, and take the value of the fuel, that in that case is going to be diesel. Get the number from the dictionary that we showed before here, and introduce the operation right here. At the end, it will return a CO2 value, and that will be thrown to the databases as in here. The only thing you need to worry about if you want to change the methodology is learning what are the variable names for all these boxes. For instance, kilometer is KMS, transport is transport, this one is fuel, this one is date, and this one is I call it gas, right? If a number is introduced here, then gas is triggered. That's why I put the test. So then the CO2s are calculated with overriding the dictionary I showed you guys before by a specific number. I put the value float here because I want this to be exclusively a float. That is a translation in Python for a decimal. I want a decimal result out of these operations. Okay, so these are the parts that you should change. Either you can change the emissions factors over there, or you can change the whole calculations from here. Remember that to make this automatic, use the variable names that are within here that are related to this section, add record boxes in here, right? Okay, that's very simple. In any case, if you have any questions or you're stuck with something, don't hesitate to give me a message. I will be happy to help you out with that one. Now, I'm going to briefly talk about the criteria for selecting a method. So we have seen across some of your groups that there are some very, very detailed methods that provides a very, very accurate descriptions of emissions. That is very good. Though you need to calculate this as a trade-off. First of all, would you go that specific? Is that the goal around your app? Or would you like to have some sort of measurement on the bigger spectrum, meaning like without that many complications? Try to think about it and try to think where is the middle ground between those two, because you can have very detailed methods out there, such as the methods that has air resistance, where you need like have weather and you need to make forecasting of weather, or things related to the specific label of the car, the specific weight of the car, etc., etc. I mean, you can do those. As far as you could see, they're easily implemented within the app, though the issue might be in the cases of the inputs. Where are the inputs? Are the inputs there? Are they available? Are they shipped? That's another question you need to follow up. So a first criteria that I'd like to include in here is like, how reliable is the method? Is the method that you brought source from a reliable source? Meaning either a peer-reviewed scientific paper or a method from an international organization that has been largely scrutinized within panels of scientists or specialists. And I think that the most important thing is like try to think you as a user would trust this method to keep your measurements, meaning that once you finish with these calculations, will you without hesitation transfer that to somebody else? So these are the type of things that I at least myself like to think when I'm building something. Try to think it in the position of the user. Another important criteria is that are the methods inputs available? If they're not available, can I build a code myself to absorb such inputs? Can I do, for instance, within the app, put an option so they can recognize the GPS position from the cell phones? Is that something that I would like to do? Is it cheap? Or is there a private company that can provide such inputs at the rate that I need and within my budget? So those are the things that you like to think whenever you're trying to select a specific method, or at least the level of accuracy of a method. Have you realized there are even methods within some respectable sources that does not include a large detail, and they do so in order for having people like you guys developing solutions to not be like an extreme, to don't hesitate to do the project because you don't have an extreme level or high level of detail, right? So those are some of the basic options. So this video, as I mentioned you, is going to be shorter because next week, week 10, that's not this Monday, but the next Monday, all of you will have a midway presentation. When I mention all of you, one presentation per group, that means. Each presentation of approximately 15 minutes. We'll try to make it to fit within the first hour of class before the break. In there, you can introduce your own experiences within the app, the learning outcomes, things that you have learned yourself, some questions that are still up there that you haven't clarified, the ups and downs of your own experience, where it was easier for you to do this, where do you find it more difficult, but more importantly, and something that could not miss this session, is the reasons why you have chosen a specific method as your default for the app. That is, describing the pros and cons behind that method. Alright? So, to give you some slack to prepare your presentation, these week tasks are going to be the following. First of all, the app development. Meaning that you can adjust the code, the app PY, to include your team selected method. Remember, once again, and I encourage you to do this, to play around with the app. Before doing anything, create a backup of both the repository. You can create it, the backup, you can download it and keep it in your desktop, and create a backup of the app PY file inside the repository. I mentioned that in one of the previous slides. The Diary team posed an answer to the following question: what other input values would you use to improve your calculations? When I'm talking about input, it could be anything. It could come from knowing the brand of the car, the year of the car, the wear or tear, the GPS positions of the car, or the transport mode, etc. And how would you get them? You can put easy solutions, you can describe easy solutions, cheap solutions, or you can think that there's no limits in budget and you can just go for the best, more expensive solutions that you see out there. The methodology team have an important task this week. You will describe the pros and cons of your selected model. You will lead the app development to include the model that within the group you guys have discussed. And we'll work together with the app development group to deploy that as part of your code. And include this information in your team's week 10 presentation. Without further information, I hope that you guys have a productive week, and I first of all like to congratulate all of you because so far I've seen a great development, a great learning curve within all of the team members. I have received a lot of messages, including lots of interactions, and that makes me extremely happy. So this is a milestone. Our apps are up and running. Those are very close to be, and I'm sure they are because I've supervised that myself, and I realized that there's some tweaks to do in some of your apps. And I encourage you guys to use the app for your final project and find solutions out there from your own records. Identify problems, identify questions within your databases. So hope you guys have a happy week, and see you next time.